Hello and welcome to your first tutorial on insertion sort. I hope you enjoyed bubble sort and are ready to move on to a new algorithm. And I also find that insertion sort is probably the most intuitive sorting algorithm. If you had to just develop your own sorting algorithm on your own, this is probably the most likely one you'd come up with. Because if, say, in real life you had a deck of cards and you were sorting them in ascending order, this is most likely the method that you would use. So let's get started with the definition/procedure on how to implement insertion sort. So in general, the way insertion sort works is it slowly accumulates a sorted list by choosing one element each iteration and finding its correct location. So you're really focusing on one element and finding its location each time you iterate through the dataset. So we're going to start with the second element. So if the second element is smaller than the first, you're going to replace the first element with the second and the second element with the first. So essentially you're going to see a swap. So this is very similar to the beginning of bubble sort, if not actually the same. You're going to compare the first two elements and swap them if necessary. So now what you have essentially is a two-element sorted list. The first two elements in this data set or in this array are going to technically be sorted in ascending order. So now this is really where insertion sort kicks in, is the third element, where you start to see the distinction. So you're going to compare the third element to the second element. So we're going to sort of iterate in descending order here. It's going to be sorted in ascending order, but we're just incrementing through it backwards. So we're starting with the third element. We're going to compare it to the second element. And if the third element is smaller than the second, we know that this element has to be shifted down. So we're going to compare it to the next element below it, and we're going to keep comparing until we finally hit an element that is larger, until we hit the last element that is larger than the one we're comparing. I hope I'm not confusing you too much, but trust me, bear with me. So essentially we're going to, if you can think of it this way, compare the elements until it finds its correct spot in this accumulated list. And we're going to repeat this until we hit the end of the list. So let's kind of visualize this here. Like I said, we're going to start with the second element and compare it to the first. Since 2 is smaller than 3, we're going to replace 3 with 2 and 2 with 3. We're going to do the switcheroo there. And now those two are sorted. So now we're going to look at the third element and compare it to the second. Well, the third element is larger than the second. So we already hit the last element that is larger than 3. So 6 isn't going to move at all. Those first 3 elements are already sorted. Now we're going to look at the fourth element and compare it with 6. 6 is larger than 4, so we have to move 6 up. We're going to replace 4 with 6, as I said, but we're still using 4 as our comparison, so this is going to be stored in like a temporary variable, but we're going to compare 4 to 3. Well, 6 was the last element that was larger than 4, so we stop. So now we replace 4 with where 6 was, and now the first 4 elements are sorted. And now we're going to compare 5 to 6. 6 is larger than 5, so 6 slides up. We're going to compare 5 with 4. And just as it was previously, 6 was the largest element because 4 is smaller than 5. So 5 slides in right there. And now we're going to compare the last element, 1, with 6. 1 is smaller than 6, so 6 is going to slide up. We're going to compare 1 with 5 now. Well, in this case, 6 was not the last largest element, so 5 slides up as well. We're going to compare 1 with 4. 4 is going to slide up. We're going to compare 1 with 3. 3 is going to slide up because 3 is larger than 1, of course. And lastly, 1 and 2 are going to compare. 2 is larger than 1, so 2 slides up, and 1 goes in at the very beginning. Hopefully that visualization helped you a little bit out there. I always think that the visualization really helps it come together, but maybe even more so will the code. So we're going to check out the Java implementation of insertion sort in the next tutorial. I'll see you there.